Good evening, class, and welcome to Lesson 3.3, Compare and Order Decimals. Let's begin by taking a look at our essential question. How can you use place value to compare and order decimals? Well, let's begin by looking at our Unlock the Problem. The table lists some of the mountains in the United States that are over 2 miles high. How does the height of Cloud Mountain in New York compare to the height of Boundary Mountain in Nevada? Well, we have our chart here, or our table, and the title of our table is Mountain Heights. On one side of our table, it has the mountain and state that they are found in, which would be Boundary, Nevada, Cloud, New York, Grand Teton, Wyoming, or Wheeler, New Mexico. And on the other side of our table is the subtitle Height in miles. So we see that Boundary, Nevada is 2,488 miles. Cloud, New York is 2,495,000 miles. Grand Teton, Wyoming is 2,607,000 miles. And Wheeler, New Mexico is 2,493,000 miles. Now, one way that we can do this to answer our essential question is to use place value. So we would line up the decimal points. Start at the left. Compare the digits in each place value position until the digits are different. So step 1 is to compare the ones. We have all of these that have a 2 in the 1 column, or in the 1 place value. So since we are comparing Cloud Mountain in New York at 2,495,000 to Boundary Mountain in Nevada at 2,488,000, we see that both of them have 2's. So 2 equals 2. So step 2 is to compare the tenths because we have to work our way right. So we see that this one has a 4 in the tenths place value, and this one has a 4 in the tenths place value. And therefore, 4 equals 4. So step 3 is to compare the hundredths. So we have a 9 in the hundredths place value here and an 8 in the hundredths place value here. And we know that 9 is greater than 8. So since 9 is greater than 8, then 2,495,000 is going to be greater than 2,488,000, and 2,488,000 is less than 2,495,000. So the height of Cloud Mountain is greater than the height of Boundary Mountain. Another way that you can do this is to use a place value chart to compare. So compare the height of Cloud Mountain to Wheeler Mountain, and you put in all the numbers according to their place value. So again, we see that 2 equals 2, 4 equals 4, 9 equals 9, and 5 is greater than 3. See that 5 is greater than 3. So since 5 is greater than 3, then 2,495,000 is greater than 2,493,000, and 2,493,000 is less than 2,495,000. So the height of Cloud Mountain is greater than the height of Wheeler Mountain. So look at another example. It says that Whitney Mountain in California is 2,745,000 miles high. Mount Rainier in Washington is 2,729,000 miles high. And Mount Harvard in Colorado is 2,731,000 miles high. Order the heights of these mountains from least to greatest. Which mountain has the least height? Which mountain has the greatest height? So step 1, it says to line up the decimal points. There are the same number of ones, so circle the tenths and compare. So the next one we would do is we would circle, and I'm not actually going to circle the tenths in each one because that's going to be a little bit difficult. But we see that each one has a tenth of 7. So 7 equals 7. So the next one, step 2, says to underline the hundredths and compare. Order from least to greatest. So we are going to take a look at our hundredths, and we see that this one is 4, this one is 2, and this one is 3. So we know that 4 is the greatest. We know that 3 is the next greatest, and 2 is the smallest. So that's the heights in order from least to greatest. So we're from smallest to largest. So if we do those heights according to that, we see this is going to be number, from least, this one's going to be number 1, this one's going to be number 2, and this one's going to be number 3. So in order from least to greatest would be 2 and 729 thousandths to 2 and 731 thousandths to 2 and 745 thousandths. So Mount Rainier has the least height, and Mount Whitney has the greatest height, because we see Mount Rainier was number 1 for least, and Mount Whitney was the greatest from least to greatest. So we can also use a place value chart. What is the order of 1 and 383 thousandths, 1 and 321 thousandths, 1 and 456 thousandths, and 1 and 32 hundredths from least to greatest? Now the first thing that you may think about is that this one may be the smallest because it's got the fewest numbers. However, in order to prevent making that mistake, make sure that you line up those decimals. So we begin by writing each number in the place value chart. So we've got 1 and 383 thousandths is done for us. 1 and 321 thousandths is next. 1 and 456 thousandths is next. And 1 and 32 hundredths is our last one. So we're going to compare the digits, beginning with the greatest place value, because we have to do greatest to least. So we're going from biggest to smallest. So we're going to compare the ones. And if we see, all of them have the same ones. So 1 equals 1. Then we're going to compare the tenths. We see we have a 3, a 3, a 4, and a 3. So we know that 4 is greater than 3. So the greatest number is going to be 1 and 456 thousandths. So let's put a little 1 over there. All right? And then we're going to compare the hundredths. So if we go down through the hundredths, we see that this one has an 8, this one has a 2, and this one has a 2. Well, we know that 8 is greater than 2. So the next greatest number is going to be 1 and 383 thousandths. So let's put a little 2 up there by that one. So next is going to be to compare the remaining thousandths. And if we see, this one has a 3, this one has a 1, and this one has a 6, but this one has nothing. Well, when that happens at the end of a decimal, when it doesn't have the same number of digits as the other ones we're comparing, we simply put a 0 in there. So now we have to compare the 1 to the 0. And we know that 1 is greater than 0. So the order of the numbers from greatest to least would be 1 and 456 thousandth, 1 and 383 thousandths, and then we know that this one's going to be third because 1 is greater than 0, and this one's going to be fourth. So continuing on would be 1 and 321 thousandth, and 1 and 320 thousandth. All right, there's not going to be a problem of the day today. Make sure that you have our password of recorded in your binder or on your math page, and bring it with you to class tomorrow. See you then.